You all my lecture series of automata theory. In the last video we have seen what is the automata and what are all the basic concept of an automata like language, grammar and automata. In today's video we are going to see about the topic of central concept of an automata theory. So I recap the last video. Theory of automata, it is nothing but it is a theoretical branch of computer science and mathematical. It is an abstract machine. The abstract machine is called it as an automata. The main motivation began that developing the automata theory is to we are used to know the machine and also what are all the operation that can be performed on that machine. So the automation is consist of a state and transitions. The states are represented by the circle and transitions are represented by the arrows. So the types of automata, we have three types. One is the finite automata, other one is the push down automata and Turing machine. So the finite automata is again classified as a deterministic finite automata and non-deterministic finite automata. So in the next video we will see the classification and differentiate between that DFA and NFA. So the types of automata is distinguished in terms of an memory. The finite automata contains no temporary memory. So we have get the input and process and pass that input as a next state as it is. So there is no need of temporary memory in the finite automata. But in the push-down automata, we have a temporary memory as a stack. All we know that what is a stack. Stack is a last in first out order. Here we are using the push and pop operation. So for that state to next state transmissions, so for the state information is stored in the temporary memory. It call it as a stack. Next is a Turing machine. Turing machine is need the more than it need more memory compared with the push-down automata. So for that we are using that random access memory in the Turing machines. So in terms of memory, the finite automata does not require any memory, and push-down automata it requires a temporary memory as a stack, and Turing machine is require the random access memory. So the finite automation, we have an input and do the automation and produces an output. So the example of a finite automata is a vending machine. Vending machine is a small computing power. There is no need of more memory or temporary memory in need that vending machine. So next is the push-down automata. So in the push-down automata, instead of that FSA, we had the temporary memory as a stack. So that is the diagrammatical representation shows that we have a input unit, and from the input unit we go into the push-down automata machine, and for that input symbol storage we need the stack, that is a temporary memory. From that, based upon the transitions, we produces an output. So the example of a push-down automata is the compilers. It requires the medium computing power. Next is the Turing machine. Turing machine in the terms of memory, the Turing machine is requires more memory compared with the push-down and finite automata. So for that Turing machine we requires the random access memory. So the highest computing power applications are uses that type of automata like a Turing machine. So that is that suppose robotics and some applications requires the highest computing power means that uses that Turing machine. So based upon that memory, finite automata requires the less memory, and push-down automata requires compared with more, and Turing machine requires the more memory. So based upon the computational problem, we select which automata we required. So this is that classification based on the memory and also the language recognition, and where we can use that automata in the real-time application. So the finite automata, it uses the regular languages. The applications of the finite automata is an elevators, vending machines and a traffic light, So the application requires the small computing power that uses the finite automata. And second one is the push-down automata. The push-down automata, the language recognized by the push-down automata is the context-free languages. The memory required in the push-down automata is the stack memory. So the in real-time applications, the compilers are using that push-down automata. So the compiler requires a medium computing power. Next is the Turing machine. The Turing machine, the language is that computational, computable language like the unrestricted grammar and lambda calculations are used as the Turing machines. So the memory management is a random access memory. So any algorithm requires the highest computing power uses the Turing machine. So this classification shows what is the language and what are all the real-time applications are used by the different types of an automata. So all we know that before going into that automata and types of automata, we should know the key terminologies of the things we used to implement that automata. One is the symbols. Symbol is nothing but it is a collection of an individual object which can be a letter, alphabet or any pictures or any symbols. Next is an alphabet. Alphabet is a finite set of symbols. The alphabet is denoted by the sigma. It may be for example, sigma is equal to a comma b means that language contains only the input symbols a comma b. Next is the string. For example, the finite collection of symbol from the alphabet. So next in that example we are having a various a comma b. The various strings that can be generated from the sigmas are AB, AA and triple A. So from the AB we can represent any set of strings. So the string with zero occurrences of symbol is known as an empty string that can be represented by this epsilon. So the number of symbols in a string W is called the length of the string. It is denoted by the length of W. So that is the length of string is represented. Next is the language. Language, it is nothing but the collection of an appropriate strings. The language which is format over a sigma can be a finite or infinite. For example, considered from the string we can derive the language is a set of string of length 2 means. So what are the strings we can derive from that alphabet of length 2, AA, BB or BA or BB or AB. So these are all the set of strings we can derive. Next example for the language is set of all the strings start with A. The starting symbol should be A followed by any combination of A or B. So that is a infinite language. So language, it is a two types. One is a finite, other one is a infinite language. So other than that language, so we know that what is a string, what is an alphabet, what is a language. So these are all the key terminologies are required to describe the string in terms of a language. I hope that in that video we know about how that three types of automata is differs and what are all the basic key terminologies are required from the language. Thank you.